Alright, today we're going to talk about implicit differentiation. And so we're going to differentiate both sides with respect to x. And instead of having f prime or y prime, we're going to go ahead and write dy dx because it'll help you understand where do I need to put all my dy dx's. So we're going to collect all our dy dx's terms on the left side, and we're going to move everything else on the right side. And factor out our dy dx, and we're going to solve for dy dx, which is our y prime, f prime, g prime, by dividing by whatever's left in the parentheses. So things to be aware of. Make sure you use the product rule. So we use implicit differentiation when I have a mixture of x and y. For example, think about a circle. A circle is not y equals. A circle is x squared plus y squared is equal to 25. And so we use implicit differentiation when my y's are mixed into the equation, and I can't get the whole entire function in a y equals form. I could solve for y for my circle, but then I have to worry about this whole plus or minus stuff. What implicit differentiation does, it eliminates this plus and minus and allows me to find the derivative all in one shot. Make sure you use parentheses so you distribute any negative signs that you may have. And again, always remember the derivative of a constant is 0. Number 1, find dy dx for y to the 4th plus y to the third, or x to the 3rd, y to the 5th, minus 2x to the 7th is equal to 13. And again, like above, I said make sure you be really careful. I have the product rule going on here. There's my first, and here's my second. So let's go ahead and find dy dx. So we're going to take the derivative of y to the 4th. And anytime we're taking the derivative, we're always going to divide by dx. And so here we're going to have y to the 4th will be 4y to the 3rd. And so I'm taking the derivative of y, that was what dy means, with respect to x, with respect to the derivative of x. Alright, and now I'm going to go to the x to the 3rd. Well, here I'm going to use the product rule. So the derivative of the first is 3x squared. And again, I'm taking the derivative with respect to x. So this will be kind of saying the derivative, I just took the derivative of x, so it'll be the derivative of x with respect to x. And I'm going to multiply that by my second and add it to my first times the derivative of my second. The derivative of the second is going to be that 5y to the 4th. And again, anytime I'm taking the derivative, I'm going to take the derivative of my term, dy, with the respect to x, that dx. And the derivative of negative 2x to the 7th will be negative 14x to the 6th. Again, I'm taking the derivative. This was an x, so it's going to be dx. That was my derivative of my x that I just took with respect to x. So notice in the denominator they're all dx's. And finally, the derivative of 13 is 0. And so if you look at these, notice how I have dx's over dx's. I hope you recognize these guys actually cancel. This becomes 1. And this becomes 1. Please don't cancel out dy dx's because then we're not talking about the same type of term. So what we really have, whoops, is 4y to the 3rd, and I'm going to highlight my dy dx in red, dy dx plus 3x squared y to the 5th plus, I'm going to move my coefficient in the front, 5x to the 3rd, y to the 4th, dy dx minus 14x to the 6th and set that equal to 0. Excuse me. And if you notice, everything that has a little red thing attached to it has a dy dx attached. Eventually we're going to factor out that red part. And so I'm going to underline these are the terms that don't have dy dx attached to it. So I'm going to move them to the right side. So I'm going to rewrite everything else. 4y to the 3rd, dy dx, and plus 5 x to the third, y to the fourth, again dy dx. And that's going to be equal to, and we're just going to write the opposite sign. So instead of writing positive 3x squared y, we're going to write negative 3x squared y to the fifth. And instead of writing negative 14x to the sixth, we're going to write positive 14x to the sixth. Alright, so now we have these red dy dx's. And so what I'm going to do is I'm going to divide out my dy dx's. And so dy dx is, here's my factor. Everything that remains is going to be in that green part. 4y to the third plus 5x to the third, y to the fourth. And that's still equal to, whoops, negative 3x squared y to the fifth plus 14x to the sixth. And so now that I'm going to have my parentheses, I just want dy dx by itself. So I'm going to divide what's in the parentheses. So divide by 4y to the third plus 5x to the third, y to the fourth. And I'm going to divide out on the other side. Parentheses 4y to the third plus 5x to the third, y to the fourth. And so on the left hand side, these guys will cancel, and that's what I'm left with finally, just with my dy dx. And so dy dx again means y prime f prime. So this is the slope formula, kind of like 2x is the slope formula for x squared for this particular problem. Number 2, find the instantaneous rate of change at the point 1, 1 for x plus 2xy minus y squared is equal to 2. And so I've given you both the point of the x and y coordinates. Sometimes if I only give you the x coordinate, you have to plug into the original and solve for y. But in this case, I went ahead and gave it for you. So let's go ahead and take our derivative. So derivative of x is 1, 1. And then again, remember we're going to do derivative of x with respect to x. So 1 dx over dx. Plus, and then we're going to take the, again I have the product rule, so the derivative of the first times the second. So here's my first, 2x, my second is just my y. So derivative of my first is 2, and then again anytime we're taking a derivative, it'll be dx over dx times my y. And I'm going to add that to my first times the derivative of y. Well, derivative of y is 1 derivative of y with respect to x. And then I'm going to take the derivative of negative y squared. So this will be minus derivative of y squared is 2y, and I'm going to multiply by dy dx. And I'm going to set that equal to, well, the derivative of 2 is equal to 0. So I'm going to go ahead and cancel my dx's and write my dy's in red. So I have 1, whoops, wrong color, 1 plus, let's cancel this as well, plus 2y plus 2x dy dx minus 2y dy dx, and that's equal to 0. So I'm going to move everything else that doesn't have a dy dx attached to it, these guys, move them to the right. So I have 2x times dy dx minus 2, wrong color, minus 2y dy dx is equal to negative 1 minus 2y. And so now I'm going to factor out that dy dx. So dy dx, and then I have 2x minus 2y is equal to negative 1 minus 2y. Alright, at this point, let's go ahead and plug in, because its numbers are a lot easier to work with. And so I have dy dx times, well, x is 1 and y is 1. So I have 2 times 1, which is 2, minus 2 times 1, which is 2, is equal to negative 1 times 2 times 1. So this will give me negative 3, divide both sides by 0, and I have a problem. And this is going to lead into the next video. When I have a 0 in the denominator, this is where my tangent line, so we're talking about an undefined slope. So I have a vertical tangent line. And so we're talking about m, we're going to say m is undefined. Number 3, if x squared plus y squared is equal to 25, what is the value of the second derivative of y at the point 4, 3? So let's go ahead and take our first derivative. So the derivative of 2x is going to be 2x, and again I'm going to write derivative dx over dx. I think I proved to you it's 1. So dx over dx cancels, plus derivative of y squared is 2y dy dx is equal to derivative of 25 is 0. And so let's go ahead, we're going to keep our dy dx and we're going to move that 2x to the other side. So I have 2y times dy dx is equal to negative 2x, and then I'm going to go ahead and divide by 2y. I don't need to worry about factor anything out. These will cancel, and so I have dy dx, whoops, is equal to, well, negative 2 over positive 2 gives me a negative x over a positive y. And so if I was going to go ahead and plug in, so I know the actual numerical value, x is 4, y is 3, so if I was going to plug in evaluating at the point 4, 3, this would be equal to negative 4 over 3. Be careful, we're not done because I asked for the second derivative, so I'm going to use this first derivative right here and take that derivative again. So the second derivative gives me the second derivative of y with respect to x. And so I'm going to use my quotient rule. So low is y, so low times the derivative of high, which is negative 1, minus my high, negative x, times the derivative of low, and so I take the derivative of y with respect to x, so this will give me dy dx all over low, which will be y squared. And again, we're going to evaluate this at 4, 3. So let's go ahead and plug in these points. So this will be equal to, well, y is 3, so we have negative 1 times 3 gives me negative 3, minus, well, negative x will be negative 4 times the derivative of y with respect to x. Well, we found that out up here. That was our negative 4 over 3. So let's go ahead and plug that in. So negative 4 over 3 all over y squared. So 3 squared will give me 9. And so this is negative 3 minus 16 over 3 all over 9. And we actually can just go ahead and stop right here.